Quick review, section 2.5, writing a polynomial function. Students will be able to write a polynomial function given the real and complex zeros. Alright, let's try our first problem. So for this first problem, it asks us to find a third degree polynomial that has the given zeros of 0, 1, and -2. Alright, let me get a pen. Okay, so since we're given these zeros, we have to think about what factors they represent. So let's go ahead and name our function f of x. So this first zero, this is where the graph crosses the x-axis. But if we were to write as a factor, it would be represented by x minus 0. Similarly, this is a 0, but as a factor, it'd be x minus 1. Same thing on this one. As a factor, it would be x minus -2. Okay, so it's always x minus whatever the 0 is. So 0, 1, and -2. And then we're going to simplify, multiply, and then we'll have our polynomial. X take away 0 is x. X minus 1 is x minus 1. Negative makes a positive. Continue to multiply. Multiply these two. So I have x. X times x is x squared. Combining like terms, I'll get plus x minus 2. Continue to simplify and distribute. So x to the third plus x squared minus 2x. So this is my third degree polynomial that has zeros of 0, 1, and -2. Let's try another one. Find a fourth degree polynomial that has the given zeros of -1, 2, and -3i. Start out the same way. So we're going to name our function and write this a little bit differently. I'm going to go ahead and recognize that if it's fourth degree, I'm given 1, 2, 3. The other 0 is technically positive 3i, and that's where I have this little note on the bottom. Complex numbers always come in pair, a plus bi and a minus bi. So then I'm going to start by writing x minus, and I'm going to repeat it 4 times. It's 1, 2, 3, and 4. Okay, so if it's a fourth degree polynomial, I'm going to have 4 factors. And then I'm going to put in my zeros. Let me grab a different pen color. So it'll be -1, 2, -3i, and positive 3i. And now we have to simplify and multiply to get to our polynomial. Start with these two. This is going to become x plus 1, x minus 2. This I'm going to simplify to x plus 3i. That's x minus 3i. Multiply these two, then I'll multiply these two. So if you multiply by distributive property, x times x is x squared. Middle terms will give you -x, and then minus 2. Careful when you multiply these two. Right? So if we use that window method or the Punnett square, let's see what happens. I'm going to do it on the side here. So I have x plus 3i, x minus 3i, draw my box, divide it into the correct number of columns and rows. X times x is x squared. X times 3i, you write that as 3ix. This is -3ix. -3 times positive 3 is -9. I times I is I squared. Now we can see these are identical terms. Those are going to cancel out, giving me 0. -9i squared, this is equivalent to positive 9. Remember, I squared is the same as -1. -1 times -9 is positive 9. So when we're multiplying these two, that's one way of going about. You get x squared plus 9. But when you have a plus bi, a minus bi, and they're complex numbers, the shortcut is x times x is x squared, you're going to get a positive, as we saw here. 3 times 3 is 9. Okay, either way. Got to continue to multiply these two. So I'm going to do that on the side here. So you can use distributive property, the box method. I'm going to go ahead and use the distributive property, but I'm going to go this direction. X squared, x to everything. So I have x squared times x squared is x to the 4th. X squared times minus x is minus x to the 3rd. Then minus 2x squared. And then I'm going to do the same thing with the 9. Distribute that through. So 9x squared. I'm going to start lining things up if I can. And you can see I'm going to be out of room here. 9x squared. And then I want to have minus 9x. And then minus 18. I'm going to write that on the side here. So the only two terms that I can combine are these two here. So that's going to give me x to the 4th minus x to the 3rd plus 7x squared minus 9x and minus 18. So there's our 4th degree polynomial with the zeros of -1, positive 2, negative 3i, and an implied positive 3i. Let's try one more. Okay, for our last one, we're trying to find a 3rd degree polynomial that has the given zeros of -1, and then we have the square root of 3 and negative square root of 3. Start out the same way. I know I want to have 3 distinct factors because of this 3rd degree. So it'll be x minus, leave a bit of room, x minus, and I need one more. And now I'm going to fill in the factors, the zeros that I'm given. Let me change my pen color. So -1, square root of 3, and negative square root of 3. Okay, and now we just have to simplify and multiply. So I'm going to clean this up a little bit. So I have x plus 1, x minus square root of 3, negative because of positive. And now on this one I'm going to start with these two. So when I have two binomials, they're identical except for the signs, then it becomes really straightforward to multiply. X times x becomes x squared. The middle terms are going to cancel, and you can see that these two and these two, they're going to cancel. So I'm not going to have to worry about it. I'm going to worry about these two here. Negative positive is negative. Square root of 3 times square root of 3 is just 3. Continue to multiply. On this one I'll go ahead and use the box method or the window or the Punnett square. So x plus 1, x squared minus 3. Draw my box. And then I'm going to multiply to get each box here. X to the 3rd minus 3x, x squared, and then minus 3. Let's see, I don't see any like terms, so I just have to write it from the highest exponent to the lowest or the constant. X to the 3rd plus x squared minus 3x minus 3. There we have it, our 3rd degree polynomial with the given zeros.